So you have covered this topic in theory of computations also. I'll be going through this entire thing once again. And to start with, so where there are three basic operations on regular expressions which are performed on Thomson's. First is star operation, second is concatenation, and third is OR operation. And for each operation, we need to build a NFA with epsilon using specific rules which are compulsory for Thomson's construction. If I talk about A star, simple machine will be of the type which is mentioned over here, that is just a single self loop on QF, which is serving as a start state as well as final state. But if I talk about Thomson's for A star, then I have compulsorily 4 epsilon moves. One is from Q0 to Q1, another is from Q2 to QF, and one there is a direct move from Q0 to QF, and there is a reverse move from Q2 to Q1. Now, why we have these 4 constructs? If I talk about that I need star with the power of 0, that means there is no A, we need to go directly. In that case, we will cross from Q0 directly to QF using this black line which is shown over here. So this is my Thomson's for epsilon. If I want only a single A, I will just go from Q0 to Q1, since Q0 is the start state, Q0 to Q1, Q1 to Q2, and Q2 to QF, which is the final state, single iteration of A, which is covered from Q1 to Q2. Now, if I talk about Thomson's for 2A, what I'll do, I'll initially start off from Q0, move to Q1 consumed, Q1 to Q2, single input consumed, that is A. Now, since I want 2A, I will move back from Q2 to Q1 and cover the second A, and then I will move from Q2 to QF. So this is how I cover 2A. Likewise, if I want to cover NA, where N ranges from say 3, 4, 5, 6 up to infinity. So what I'll do, I'll keep on moving in this loop Q1, Q2, back to Q1 till the number of A which are supposed to be covered are completed. So this is how I draw the Thomson's for A star. So most important rule is that whenever we want to construct the Thomson's construction for star, we compulsorily need to add 4 epsilon moves, 2 new states. Here 2 new states are Q0 and QF, and 4 epsilon moves are as depicted in this diagram. Next, we move to concatenation. When we talk about concatenation in Thomson's construction, no epsilon is added. I have 2 machines, one for A, another for B. If I want concatenation A dot B, then simple machine will be A followed by B. No extra state, no extra epsilon. Then I move to A or B. I have 4 epsilon moves again as I had in star. I have 2 new states. Initially I had NFA for A, Q0 to QF, NFA for B, Q0 to QF. Now I am combining them through OR operation. I will have 2 new states, 4 epsilon moves. One from Q0 to Q1, another from Q0 to Q3, third one from Q2 to QF, and fourth one from Q4 to QF. So again, the rule remains, whenever you want to construct NFA using Thomson's construction for OR, 4 epsilons, 2 new states. Now we will solve 3 or 4 questions just for the sake of understanding. We have A star, B. We need to construct the NFA using Thomson's construction. So if I talk about A, there's a simple Thomson's construction. For B, Thomson's. For A star, as I discussed in the previous slides, 4 epsilon moves are compulsory. So what will be the output? Output will be A in concatenation with A star, which is in concatenation with B. On the right side, I have drawn a simple NFA without Thomson's, in which the same regular expression, that is A star, B, is covered. So you can clearly see the difference between the 2 NFA. Using Thomson's, we get the final output as the one which is on the top, and not using Thomson's, both are correct. Both are NFA for regular expression A, or A into A star into B. But if I say in the examination, you have to construct this using Thompson's, then the above one is the answer. If I say just construct the NFA, you can always go in for with Thompson's or without Thompson's. Next, we move to second question. A star B, A or B. In this, I have introduced OR operation along with the star operation. I very well know that Thompson's for A star will have 4A, for B, none of the above. For A or B, 4 epsilon. So in turn, I will have a machine. Just by going through the regular expression, I am clear that I will have a machine which will include 8 epsilons, 4 for star, 4 for OR. So this is the final output which I will get after concatenating A star with B and A or B. I have drawn the machine without epsilon on the right side, which indicates that A star B, A or B is covered with this machine also, but with Thompson's you need to go in for the machine with final output. Now I come to third question. I have covered this question just to make you understand a very important point which is supposed to be covered in the labs also. In the lab, I clearly mentioned that we need to have the number of states cross 4 machine. Why? In that I said that we can have only 2 epsilon moves corresponding to every state on every output. Just if I have to go in for Thompson's construction of A or B or C, I think the actual picture which comes to mind is the one which is given above. But here just note down that from Q0 I am giving 3 out moves corresponding to epsilon move. This is not accepted. 3 epsilon out moves from a single state are not allowed. Instead, we go in for the Thompson's which is given below as final output. So what I have done here is, first I have connected from Q0, I have connected 2 epsilons, one towards A, one towards another state. Then on Q3, I have again connected 2 epsilons. So this is the actual output which we will get, which is the correct answer for A or B or C. So we can never have more than 2 out moves from a single state on Thompson's construction. Please remember, this is a very important point. Next, we come to last question of Thompson's, that is A star B, A or B. So A or B, I very well know. Now I have A or B in star. So first I have A or B in A or star. I have 4 more Thompsons, 4 more epsilons. So this is the output which I will get corresponding to A or B whole star. You can clearly count, we will have 8 epsilon moves corresponding to this expression A or B whole star. Now this part Q1 to Q6 is covered in A or B, which is mentioned above, which is drawn above also. And next part, star part, is covered along with Q1 to Q6 with 4 new epsilons. So this is the final construction for A, B, A or B star. Without epsilon, the output is given at the bottom in a square bracket, Now I will move to subset construction. In subset construction, we go in for finding out the E closures. Now what we will do, first step will be that we will take the E closure of start state. Most important point, which is the last point which I have mentioned also as most important point, whenever I am taking the E closure of a particular state, that state will itself be included in the set of E closures. Now just see the example and then these steps will be clear to you. I start with E closure of 0 because 0 is the start state. If I say E closure of 0, that means all these states which I can traverse from state 0 without consuming any input. What is my input? Sigma. Sigma is AB. So that means corresponding to 0, all these states which can be covered only through epsilon. From 0, I can go to 1 and 7. So 1 and 7 have been included. From 1, I can go to 2 and 4. So 2 and 4 have been included. So E closure of 0 will include 5 states, that is 0 will itself be included, 0, 1, 2, 4 and 7. I name this as set capital A. Now I calculate capital A comma A. That means Capital A was 01247, 01247 comma A. I have 01247 comma A means 0 comma A union 1 comma A union 2 comma A union 4 comma A union 7 comma A. That means from this set, wherever I can go, only on small a move. Why I am taking small a? Because my sigma is A and B. I will take capital A, capital A, comma B. Right now I am taking capital A, comma A. Capital A set is already clear, 01247, comma A. Now just check if I traverse from 0 on A. No move, because from 0 I am going to state number 1 and state number 7, right? So there is no move corresponding to 0 on A. I move to 1 comma A. Not getting anything because 1 is moving to epsilon on 2 and 4. 2 comma A. Yes, 2 comma A I get 3. I have marked with different color. Then next is 4 comma A. Nothing. 4 is moving to B, from B. Then I move to 7 comma A, which is 8. So I have marked 3 and 8 in this case because corresponding to capital A, I am getting 2 moves. One is 3, another is 8. Now I will take E closure of 3 and E closure of 8. Earlier I took E closure of 0. When I took E closure of 0, I included all the states along with 0 on which I could traverse only on epsilon move. Now if I take E closure of 3, it will include 3 itself. From 3 I can go to 6. From 6 I can go to 1 and 7. From 1 I can go to 2 and 4. I am talking only about epsilon moves. No input, that means no A, no B. So what is the output I get corresponding to E closure 3? It is 1, 2, 3, 4, 6 and 7. I have marked them with black color. Now I take E closure of 8. 8 will itself be included, but I don't have any epsilon move, so it will be only 8. So E closure of 3 union E closure of 8 is 1, 2, 3, 4, 6, 7, 8. Since this set which I get is not same as the set which I got earlier, that means capital A, so I will mark this set as B. On the right side I have given corresponding to state A, on small a I get a new set which is B. Now I move to capital A, comma B. I have already covered capital A, comma A. Capital A had 0, 1, 2, 4, 7, comma B. I check on 0, only epsilon. I check on 1, only epsilons. 2, no output to B. 4 gives 1 output to B, which is 5. So here I will take E closure of 5. Now what is E closure of 5? E closure of 5 means all the states which can be traversed from 5 only on epsilon move. 5 itself will be included. So 5, from 5 if I traverse on epsilon, I go to 6, 6 to 1, 1 to 2, 4 and 6 to 7. So I have included all these. When I check these two, when I check this new state capital C set with A and B set, I find that the elements which are included in capital C set are neither of A nor of B. So I mark this as capital C, that means a new set. Now I go to capital B, comma small a. Now we find B, comma A. 1, 2, 4, 1, 2, 3, 4, 6, 7, 8, comma A. Again, same 1, comma A union 2, comma A up to 8, comma A. We will check in the NFA, which was 2, comma A gives us 3, 7, comma A gives us 8. So this is E closure of 3 union E closure of 8. ये हम पहले ही कैलकुलेट कर चुके हैं. So this is capital B itself. Fine. Now we have calculated capital B, comma A. We will calculate capital B, comma B. When we go in for capital B, comma B, we get capital B was 1, 2, 4, 5, 6, 7, 8, comma B. Corresponding to 4, we get 5. Corresponding to 8, we get 9. So we have a new set, E-closure of 5 union E-closure of 9. E-closure of 5 we have already calculated. So we will calculate E-closure of 9 and we will take all the values of E-closure of 5, which was actually C set 1, 2, 4, 5, 6, 7. If you see on the right side of the table, C set is mentioned. Now when we talk about E-closure of 9, 9 will itself be included, although it will not have any other move. So we get a new set 1, 2, 4, 5, 6, 7, 9. This new set is called capital D. Now we have next move, that is C comma A. It is 1, 2, 4, 5, 6, 7 comma A. If I do 1, 2, 4, 5, 6, 7 comma A, I again get E-closure of 3 union E-closure of 8, which is again set B. Now I move to C comma B. When I go to C comma B, I again get the same set, that is E-closure of 5. So this gives me capital C. I am left out only with one move, that is D comma A. When I give D comma A, it again leads me to B set. D comma B leads me to C set. So this is how I go in for Thompson's construction and subset construction for A or B star AB. This is the final output which I get. Now I need to find out what is the start state and the final state. Since 0 was my start state, all the states which have 0 will be start state. In this case, only capital A has the component 0, so it will be the start state. And all the states which have 9 number state, since 9 was the final state in my initial Thompson's construction, that will be included as final state. In this case, only D state has 9, so 9 will be included as final state. So this is the final DFA which I get corresponding to A or B star AB using Thompson's and subset construction. So this is the final output. These are the two algorithms for E-closure as well as for subset.